Yeah, so this is exercise 5. That's not really a say a control assignment. There's only one, an assignment that do process control or something like this. What we are going to do here is to make a Morse encoder. We want to use the PLC to input a text to the PLC. We can use that through an operating panel or something like that. And then we want our PLC to toggle an output that we connect to a light or something, a flashing light or sound or something that is going to be a Morse code. So I want to write in the text, and I want my PLC to use a diesel output on or on off to output a Morse code. Morse code is not used anymore, but at least not widely. But this is an assignment just to make, let's say, an advanced program, a little advanced program, an advanced function block. So let's have a little look at the assignment here. Advanced function block. It is not that advanced, but it has not. It's nothing to do by control. But let's say from the last exercise, we could Morse code our error from our PLC to shore or something using a light signal. Okay, there's an error on my PLC, and here's the Morse code. Okay, there was a transfer to high fault out there. Okay, too bad. We have to ship someone or send someone out to fix it. But I don't think we use Morse code anything anymore for that matter. So this is just for programming. Use extensive timing. We are going to use the same timing system and final state machine as was used in the lab 4, or you should do, and then to test the function block. So what we are going to program here a function block that does the Morsing, and there is an embedded function block, a function block that you can use. I want to look through it to generate this. It converts an Ascii character, which is a number for a letter that you are typing, or in a letter in a sentence or something. That's converted to an integer, and then we just find out what is the Morse code for that. We're going to look at that. Call it up to program, and you document the code. So that's what it is. Program and test. Make this Morse coder and test it that it works. So that's the assignment. And here is the background. Here's Morse codes. And Morse codes, they are dots and dashes. A dot is toot, and a dash is toot, something like that. And it's a combination of these dots and dashes that is a Morse code. The one that's commonly known is SOS, where do we have S? And SOS is 3 dots, and O should be 3 dashes. There are 3 dashes, and then S, 3 dots again. So doot, 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 doot. So there we have SOS signal in sound. We could also use a light, flash lights, long lights, short on, light, long on, and then we have a Morse code. And here are the letters in Morse code and digits. There are commas and stuff that has Morse code, but we are just going to do the letters, and that's it. Capital letters only in Morse code, and so on. Yeah, and here's a little, and then there's a what we call a rudimentary pseudocode algorithm, how to do this, whatever. This encoding, we're going to look at this code array a little later, but the encoding here is done in this encoding data block that you can use. And here is an Ascii table to a number you need, because a computer doesn't work on, the computer can't read and speak or anything, it can't read sentences. So they are just the numbers, the binary combinations here that's converted to decimal. So an A is 65, or hexadecimal 41, and so on. Yes. And then it's a Morse decoding, but you get the Morse decoder too. This uses a kind of a linear binary tree or something as the codes get in. So it just searches as it gets the code and finds the correct character for the code when you receive it. But because if you want to test this Morse coder, you need a Morse receiver somewhere to say, okay, I'm sending SOS, I'm reading SOS, that's kind of nice. I'm sending my name, I'm reading my name, fine. but we're just going to do all of this in the PLC. But if you had two PLCs, you could load a Morse code on one PLC, connect a digital output from that PLC to a digital input on another PLC, and have the decoding in the other PLC, and then you get the flashing on or on off on the outputs, and you could read it back. And these PLCs, they could be located in two different rooms, so then you could do Morse coding between two rooms. And of course you could have an instance of the Morse coder in each of the PLC and a decoder in another PLC, and then you have bidirectional. But then you would need two outputs, and let's say one output to one input in the other PLC, and then output from the other PLC to the input in another one. And then you could sit and write Morse code with decoding to each other in two different rooms if you want to do this. Now let's say that was the Morse decoder, yes, and it's only decoding numbers and letters. That's all it can do, or is designed to do. So use kind of a linear search or something like that. As the codes are getting in, you are just shifting an index, and when you have got all the codes, the index is just pointing at a letter that you want. So it's a kind of a binary search, a kind of a binary search. It's a linear binary search. These algorithms you can find on the network. They are not in PLC code there. Yes, if you wanted dashes and commas and dots and whatever special characters, this one wouldn't work. It would have to be adapted. But still, you could give it could get codes that it doesn't recognize. So either you will get the dash in here, or would be outside arrays or something. But this one can decode numbers and letters. Okay, and here is programming tips. I'm not going to go through those, but they are kind of extensive. Here are suggested variables and inputs and so on. And this is going to be a state machine. And there's an execution trigger to say, okay, I have a sentence, execute it, send it. Write a new sentence, execute it, send it, and so on. So it writes what you should do. And here is how to call your AsciiToMorseCoder. And there's a code array, because if you go back to the Morse code up here, you can see we need a code, or we need to tell that, okay, if this ASCII encoder, we're going to look at it, if input an A to it, it has to return a code for a dot and a dash. And we use the numbers 1 and 2. I think number 1 was a dot, and number 2 was a dash. So it needs an array or a vector or something with up to, we have, I don't know, here of 5, but I think a complete one has more entries. And in the one down here, we suggest, I think, dash dot, there is an array here, code array 8 codes. And here are dot dash codes 1 and 2, so I remember that correctly. End of code characters, because I have 8 in here, and the 0 says there are no more codes. I get 1, 2, that is a dot dash, was A, wasn't it? And then I get zeros. Then I'm done. And also, when we look at here, I think it's up here, it says dot or dash, or down here. Each letter, compilation of short, blah, 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 is a dot, and dash is 3 dots. So here are the timing, you give the timing. Spacing between dots and dashes in a character is 1 dot. The spacing in between here is 1 dot. The time, what the time is, I don't know. We use a parameter for that. Tell what the spacing is. 3 dots, then you are spacing between characters, and if you have more words, spacing between words are 7 dots. So the base unit is dots. And in the programming tips here, so we have variables here. Code so we have a parameter that says dot duration, it's a time 10 milliseconds or whatnot, and the pause is a dot duration, and here we have 3 times whatever. Character spacing, dash duration, they are equal, and the word spacing is 7 dots. And so on. Restart is true. So here you get the tips down here. Yes. And write to outputs. So this is the Morse. The Y is the Morse code output. That's the one that's true for dot duration, true for dash duration, and pauses, and the pause is off, of course. This is not an easy program to make. It's not a difficult, but it's not easy either. But here are some programming tips. Might not be much, but of course you get a solution or a proposal how to do this. Now we are going to move into the PLC. I think I'll sit down here. Yes, I can sit comfortably down here. Okay, so what I want to show you is you get the Morse decoder and the Ascii to Morse coder. The rest is that you need an instant data block for the Morse decoder and one for the Morse encoder, because these are function blocks, and you need to call this in the program here. And here the test is we could use an output to an input or something like that to put on the Morse code, but here in the program here, it's just the output from the Morse code is the input to the Morse decoder. Because of course, if we want to output this, it should be on an output. I think that's not. So this, the Morse code is called in main. Let's see. Yes, Morse code, so there's nothing to it, but there should be an output to it. I think there was an output. Let's see if the tag table, Morse output, whatever, we can. I can just put it in here. The program Morse code. I have to open the Morse code. So and enter here. That was the output. Tabs equals. No, I've done it. I was a little too quick. I didn't read. That was the output. So it's output. I just put this, could be in this in the simulation section or something to test this. So I basically read back. Okay, so it was okay. I'm just going to make it all green over here. So this, what we should look at the program. The IO was in there. I just sort of looked at it. The Ascii to Morse. Okay. I probably didn't show it up here, but here's how you embed a function block in another function block. I'm going to use this one. I'm going to inherit this one and use it. So I just put it into my code, and the call of it here is how it's always for function block. It's the data area that you have assigned to it that you are calling on. And the data area was called this one. It's just the same way as an instance data block, but now this is embedded in another function block because I just inherited it. But what we were going to look at is what's in this one. It has let's say there was Ascii to code. It has an output, which is an array 1, 2, 8. And because I want to set it equal to the arrays that I'm receiving. So that's an output 1, 2, 8. So it's not as sophisticated. The input is an integer, it's the character. And then I have a code array here. Because what I want to do is I want to take my integer input, which is a number between 1 and 127. And then I want to return the code. But what I've done here too is brute force. I say, okay, here, if my code array is not populated, which means that in this -1 index here, there is a 0. Then I say it's populated because my index here, if I do the constant, I have quite a bit. Just to make that, I'm going to collapse the array here. So I'm going to scroll down further. Populate is a 1. I just write something in here. So if it's not populated, I do populate. If it's populated, I'm not writing this coding into my array all the time. I say, okay, if the array is correct, I don't write anything more. That's static. It was static, so it's going to remember this one. So that's what it's returning, and we have some codes here. These are the same codes that it was in just the program. End of code is 0, dot and dash codes. So what I do is that I say, okay, I have a matrix here that's all zeros, void. And then I say, okay, the first thing I do, I run through my entire array from 0 to 127 and says void. Now, ASCII characters, if you look at the ASCII table, I think if I scroll down here, we had it up here. Let me just go back up here. You can see the ASCII table also has 0. That's 0 to a little 127. There are some extended too, and now we have Unicode with more codes, but this is a simple one. 127. So I accommodate all these numbers, capital letters and small and small letters and so on. And there's special codes and signs and parentheses probably somewhere, and backslash and code. So I could do a lot here, put in a code for everything. Now Morse doesn't have codes for all these numbers, but my ASCII characters can be this, because if someone give me a wrong character or something, my program can't crash. So if I get a number 120 in here, I have to return something, and what I am returning then is just a void. I just return end of characters, as the first entry in the arrays is an end of a character. So here are just according to the A was a dot dash, okay, a B is a dash dot dot dot, and the encoder, I get the numbers all on the bottom here. Is 0 is dash 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 is a 0, and 1 is a dot dash dash dash. You see this is shifting the dots here, that's special for the numbers, and so on. And then I output the code. So this is just coding, and here is my input, and I validate it and say that if I get a code, I don't know who's using this function, give me a code of 300 or something, that I say if it's greater or equal to 0 and less or equal to 127 is a valid code, then I just output the arrays. According to the code, I output this array. This output here is an array. It's not a single integer or something. It is an array of integers, my codes, dashes and dots. And if it's outside, I just put my void array, which is just end of code. And then I void my input. Void, this is an integer, constant integer. I just say set my input to void. So if this is running again, it's I think the void code, and check. Void is a -1. A -1 is not in here, so I output void. So remember, you get the array once, and then you get a 0 array out after that. So that's that one. Now we do a quick look too at the decode. You're just going to use it, but it's going to be in here. So you can look at the decoder, maybe get some programming tips for the encoder that you are going to make. And here are the inputs, and here is timing, and so on. And as this one also needs to know, this is a little jitter and something here, but here are the same. But it's not the same as the dot and let's say it doesn't use the same numbers for character spacing and stuff like that. That's not important, but because it doesn't have to wait that long. It should wait longer or something like that. We say message end. When the text is done, that's 10 dot duration. It has to be more than the word spacing. So if I'm waiting for 10 dot durations, it's greater than word spacing, I don't get any more codes. And the state machine here. So what it does is the algorithm that was in the assignment up here. Let's say here, if we go back up, it does this stuff here. That's what the code does. But you can look at it to get tips. This string here was special. Let's just put in that string that was in the assignment. It's just put in here because I want to look at the string. Look in the string and pick up the characters. So what it does here, it checks for pulses, positive and negative edges on my input. Do I get something? Is there a transition to a dot or dash? Do I get something? And also off. Then it's an index adjustment. This is a linear search. I have a pause, and then it's a get character. Then a decode index is if my decode index is greater than 0, because in my string there's 1 to my max string length. I don't know what it is, but this function here says the length of the decode string. And what, as we have seen, this is the input. I could delete this one. That's a standard. I could do that too. Yeah, we'll keep it. You could delete it when you get this. Then I get a letter, and I say if it's outside, I get something that's not in my string. Then I output a dot. So I get a code or something, but that's not something I can understand. So I return a dot. I could have, as this string has dashes as nothing, but I will return a dot. So if I see a dot, I'm outside. If I get a dash, I got the wrong code in my string. So just okay. So that's here. I'll wait for word splits to get in a space, and so on. The space is output here, and then wait for message end, and then it goes back. And basically, what it does is that it has an idle state in here, and says that okay, something is happening on my input. I've paused. There's no Morse code coming to me, but suddenly my input is switching to 1. I get a Morse code, and then I start to decode. So then I hop to the, I jump to, I initialize this linear search to, you can find this algorithm on the internet to decode the Morse code. But I don't. So that's what this program does. Yeah. And what you have to do is to make the Morse encoder using the tips. Of course, there's going to be a solution later. And then the Morse, make an instance data block for the decoder. You could call that Morse encoder, but that's not that, a Morse decoder. I'm going to change this to Morse encoder, so what do you call it? Let's change the name. And now, of course, I am online, so then I can change the instance data block name. I have to be offline to do that. Encode. Yeah. Okay, so those instance data block, and that's just here. Right click, new block, write the name, and find the Morse decoder down here, and so on. Yes. So you get this one and that one, and you have to make this one, but you've seen that, and call it a main, and you have to write this one. It's not an easy assignment. It's not that difficult, but it's not easy either. Okay, so this was an exercise which is programming. We would use a PLC to send Morse codes and receive Morse code, unless someone wants us to do it, and then we can do it, of course. But the PLC can program something like this, using a little, some built-in instruction with length of strings and so on. Okay, and then this has to be tested too, of course, and the test was that we have a Morse decoder. So the test is, when you test this, you should write in a string, activate Ascii, which is then Morse encoding into the decoder, and you should get the same string out. That's the general idea here of this. And then we have I use an output, so also this Morse code would flash on your PLC. And as I say, if I connected a sound device or something, 24-volt buzzer or something, it would buzz short, long, short, long. The duration here is usually should be a parameter, because when you are testing this, you need a longer time when it's running full speed, of course you need a shorter time. It depends. If there's a human that's going to look at the short and long ones, the human isn't that fast. If it's a machine that's decoding it, it can be ultra fast. Okay, so it should be a parameter, the dot duration. Okay, so that was an introduction. Good luck. This is not easy, but good luck.